So let's take a look at some of the problems from this skill 14H, where we're going to have complex numbers that's written in polar form and either multiply them or divide them. And to do that, we're going to use these formulas that were in our notes. So if you have some complex number and you just call it Z1 and you have that written in polar form, then we're just using that subscript of 1 to distinguish it from another complex number that's written in polar form that we're just calling Z2. And here in problem number 1, they've given us two such complex numbers, and they want us to multiply them together. Well, I claim that oftentimes when you multiply complex numbers, it's going to be easier if you're in polar form due to these formulas. You know, it's easier to just multiply the 5 times 15, and it's easier to add the 2 pi over 3 plus pi over 3 for these two complex numbers. And let me point that out, that those two complex numbers written in standard form, if we take the cosine of 2 pi over 3, it's in the second quadrant. Look at your unit circle. It's negative. It's going to be what? Negative 1/2. And the sine of 2 pi over 3 is going to be square root 3 over 2. So I converted that Z1 from polar form to standard form. And I did the same thing for that second complex number. Well, if I were to ask you to multiply these two complex numbers together, you would probably either do it in the form of a table or some organized way to apply the distributive property. And you can see from the table that it's not impossible, but that the multiplication is a little more difficult, you'll see, than the way we're going to do it in this homework. All right, so it turns out that when I multiply the Z1 times Z2, that one diagonal here, the terms that have my imaginary unit, those are equal and opposite, and those happen to cancel. And the negative 75 over 4 plus a negative 225 over 4, they have a common denominator. When you add those together, you just get negative 75. So this is not how the directions or how we intended you to multiply these two complex numbers together. Let's do it the way that this homework assignment intends for us to do it. And that's to use this formula. So if I have this Z1, let's identify that the R1 value is 5, and for this other complex number, the R2 value of 15. And 5 times 15 is 75. And now our formula says to take the cosine, well, to add the two angles together. And these angles these radian measures are really nice to add together because they have a common denominator. 2 pi over 3 plus pi over 3 is 3 pi over 3, which is just pi. And so you have cosine of pi plus I times the sine of pi. Well, the cosine of pi is 0. And look at the angle pi, look at the x-coordinate. No, excuse me, it's negative 1. The x-coordinate is negative 1. The sine of pi, that's 0, because if you look at pi and you look at the y-coordinate, at the angle pi, you're on the x-axis. You haven't moved up and down, so that y-coordinate is 0. So you've got 75 times negative 1. Hey, that's negative 75. That's the answer that we got through this, ugly table, and making sure that you don't make any silly mistakes in multiplying the fractions together. I got negative 75. Well, I get negative 75, only I write the negative 75 in polar form. And to multiply these two together, I think that you could easily argue that this solution is easier and faster than the previous solution, than working in standard form. So there's advantages to working in the polar form for these complex numbers. So I hope that helps, and I'll talk to you later.